Okay, we are in section 4.4 and we are looking at continuous functions defined on closed intervals. And as the theory of section 4.4 tells us, a continuous function defined on a closed interval will have an absolute max and it will have an absolute minimum. And also that these values will have to occur at the endpoints of the interval or at a critical point within the interval. So let's take an example. I'm going to start out here a couple examples. First one, let's just take a simple polynomial function, minus x squared plus 4x plus 6, defined on the closed interval from 0 to 5. This is a continuous function on that interval. And to see if there's any critical points that occur in the interval, I'm going to take the derivative and set it equal to 0. In doing that, I'll get x equal 2, and x equal 2 is in the interval. Now, the extreme values will have to occur at the endpoints or at a critical point. The critical point here is where the slope of the tangent line is equal to 0, and there could be a relative extreme value at that point. We'll compare it to the values at the endpoints and pretty much just see which is the largest value and which is the smallest. Evaluating the function at 0, I get 6. Evaluating the function at 5, I'd have a minus 25 plus 20 plus 6, and that would give me 1. And evaluating the function at 2, I'll have a minus 2 squared plus 8 plus 6, and that will give me 10. Now, from this, the absolute maximum is 10, and it occurs at the domain value x equal to 2. And the absolute minimum is at an endpoint. The absolute minimum is 1, and it occurs at 5. So to conclude this, we have an absolute maximum functional value of 10 at x equal to 2, and an absolute minimum functional value of 1 at x equal to 5. Now let's try another example. Suppose we have f of x equal to 3x to the 2/3 minus 2x, and defined on the interval from 0 to 3. Taking the first derivative of the function to find critical points, I'll have 3 times 2/3, or 2, x to the minus 1/3 minus 2. And then setting that equal to 0, I will add 2 to both sides, divide by 2, and I'll have 1 over the cube root of x, and that will imply that x is equal to 1. So looking at my endpoints as I did before in the other example, and also making sure that I look at the functional value at 1, I will get f of 0 is 0, f of 3 is 3 cube root of 3 squared minus 6, and that turns out to be 0.24025, and then f of 1 is 1. So I can see that the absolute maximum of, and what would be my largest value there, 1, and that occurs at x equal to 1, and my absolute minimum of 0 at x equal to 0.